Whilst we look at e-methane and digestate over the coming months, we initially focused our investigation on the biomethane industry's role in the production of biogenic CO₂ and how that can contribute to meeting current and future CO₂ demand. We arranged a workshop with 15 organisations from across the biomethane supply chain. Here we shared insights on topics such as the CO₂ market today and how the demand for CO₂ could develop. We also discussed the characteristics of capturing and using biogenic CO₂ from biomethane production. These contributions were incorporated into a final report along with the literature review results. The report suggests that the demand for biogenic CO₂ could be much higher than currently thought and shows the potential of biomethane production as a cost-effective and competitive source to satisfy a significant share of this demand.
Biogenic CO₂ is part of a natural cycle. It starts in the atmosphere and gets absorbed by plants through photosynthesis. And it is released back without accumulation through processes like decomposition. Fossil CO₂ comes from carbon that has been stored away for millions of years and is suddenly released when we burn fossil fuels, causing increased atmospheric CO₂ levels.
Biogenic carbon dioxide is a natural byproduct from biogas upgrading to biomethane, but it is often overlooked as a source for carbon capture.
Capturing biogenic CO₂ has usually three different uses. Carbon capture and storage, where CO₂ is stored underground, resulting in negative emission. Carbon capture and utilization, where biogenic CO₂ is used as a product, for example in the food and beverage, or as a feedstock for the production of biopolymers and fuels, replacing the use of fossil CO₂ and reducing GHG emission. And carbon capture, utilization, and storage, where the biogenic CO₂ is used in the product, for example in the cement, for long-term storage.
Current carbon dioxide market in Europe is about 41 million tons, sourced mostly from fossil fuels. This market is estimated to be up to 10 times larger by 2050.
In the near future, the largest part of the CO₂ demand will be driven in the production of e-fuels. And to develop this market in the short term, there will be the need to capture fossil CO₂ to abate emissions. And this will be allowed under the EU rules up to 2035. But one of the main questions that we've been asked by investors and industry is how the transition between this fossil CO₂ and the biogenic CO₂ will be implemented in the run-up up till 2035. Today, the CO₂ demand is provided by burning fossil fuels, but soon the traditional sources of CO₂ will be limited due to the requirements of net zero emissions. In our report, we have focused on different alternative sources other than biomethane, such as bioethanol or waste to energy. We have even analyzed direct air capturing, source of renewable CO₂, but even the more optimistic cost estimation do not show this to be a cost-competitive process. On the contrary, biogenic CO₂ coming from biomethane upgrading, considering the low cost of energy required to liquefy the CO₂, looks to be, in the long term, one of the most competitive processes to provide CO₂.
The biomethane production target of 35 BCM per year by 2030 will produce 46 megaton of biogenic CO₂. Based on the estimates of the European Biogas Association, this number could rise up to 124 megaton per year by 2050. and others suggesting that this number could even rise up to 200 megaton per year by 2050.
There are several aspects that need to be addressed when developing the market of biogenic CO2. Purity is one of those, cost and complexity of logistics, availability of renewable energy to liquefy the CO2, and a way to calculate the GHG reduction emission. Another key point that will have to be clarified for sure in the near future is a proper and agreed way to certify the biogenic CO2.
Markets and certificates for biogenic carbon dioxide play a key role in driving CO2 capture from biomethane production, but also from other sources. Certificates could be part of existing biomethane certification system, but there could be also specific biogenic CO2 certificates of origin.
Biomethane is a cost-competitive, technology-ready source of renewable biogenic CO2, with the potential to supply over 100 million tonnes of this demand. Combining this biogenic CO2 with hydrogen for e-fuels, with CCS for negative emissions, and with innovative construction products and biopolymers, to name a few, will provide exciting renewable market opportunities in the future for biomethane producers. Finally, developing effective logistics and supporting policy frameworks are crucial for realising this potential, and creating a biogenic CO2 certificate will be a helpful step forward.